For my first equation, I chose number 3, where it's talking about two identical twins, and you have to distinguish which one is lying. So the first one says, one twin tells you a lucky number pair. When I multiply my first lucky number by 3, 3x, and my second lucky number by 6, 6y, those are just my variables. The addition of the resulting numbers produces a sum of 12. So that means 3x plus 6y equals 12. Then it says, when I add my first lucky number and twice my second lucky number, variables again, the sum is 5. So now we have to see which twin is talking by seeing if this statement is true or false. So there's two ways to do systems of equation: substitution and elimination. First, we're going to start with elimination. Doing that, I'm going to keep the top one the same, 3x plus 6y equals 12. And I'm going to multiply the bottom by -3 to make the x's cancel out. So that gives me -3 minus 6y. And it happens to be that they both cancel out. Equals -15. So then you would cancel, 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 cancel. 0 equals -3. That doesn't make sense. So that is a lie. So we can conclude that the twin that we got is the one that's lying. But just to double check, triple check, we can use the different method, which is substitution. And by doing that, you have to isolate one of the variables. And in this equation, it just makes it easy because x is already by itself and has no coefficient. So let's do x equals 5 minus 2y. Then you take the top one, 3 parentheses, because you replace x with 5 minus 2y. And then you finish out the rest of the problem, plus 6y equals 12. Now you have to distribute because that's the first step. So you get 15 minus 6y plus 6y. Now you just solve 15 minus 6y plus 6y. That makes 15 minus 0 because these cancel out, equals 12. 15 equals 12. Nope. So that just confirms what we thought originally. And both these systems of equations, these different methods of system equations, prove that we got the twin that is lying. Twin is the liar. That is question 3 and the first one for the math project. Thank you. Okay, so for my second equation, I chose number 4, where it's pretty much a question that you have to set up 3 systems of equations, and it's talking about triangles, rectangles, and pentagons, and you have to conclude the amount of each in the paintings. So first, I started with making 3 equations for my 3 systems of equation, and my first was x plus y plus z equals 40, then 3x plus 4y plus 5z equals 153, and then finally 2y plus 5z equals 72. Then I got 2 of the 3, because that's the first step in 3 systems, and so I chose x plus y plus z equals 40, and 2y plus 5z equals 72, because this y is already there. So then, breaking it down, I multiply by -2 to make the y's cancel out, and that gives me -2x minus 2y, making it cancel out, minus 2z equals -80. Then I keep this bottom one the same because it's already positive 2y, and that's -2y. So it'd be 2y plus 5z equals 72. Then you would add them together, and you would get your first system. That's the first system to determine what either x or z would equal, because you have to break it down to 2 systems at a time, and then you get your final answer. So it would give me my first system, which is -2x plus 3z equals -8. Now, moving on to step 3. That's where I choose 2 more different ones. They can't be the same. One has to be different. And I have to find the same variable. I use the same variable, y. So I use 3x plus 4y plus 5z equals 153. And then I use 2y plus 5z equals 72. So, by doing that, I multiply the bottom by -2 to make the positive on this positive 4y and this negative 4y cancel out. So I multiply the bottom by -2, and that gives me 3x plus 4y plus 5z equals 153 on the top, and on the bottom, -4y minus 10z equals -144, because you would distribute the 2 all the way through. Then, that would move on to 3b, my next step, which is making it simplifying it, which would give me 3x plus 5z equals 153, and that would leave me just with z on the bottom, to -10z to be specific, equals -144. Then you would add them together, the equation, you would get 3x minus 5z equals 9. Now, we got one system of equation on top, now we got another system of equation. Now we use these 2 systems to solve for one of the variables. So, you get -2x plus 3z equals -8, this one right here. -3x minus 5z equals 9. These have the same variables, so you know you're on a good path. Now you have to make them one of the variables cancel out. So I choose x, and I choose the lowest common denominator, which would be 6. And I make this 6 by multiplying the top by 3. So that would make everything else -6x plus 9z equals -24. And on the bottom, you have to also make it +6, not -6, so they can cancel out. So I multiply everything on the bottom by 2, which will give me 6x minus 10z equals 18. Now the x's will cancel out, and I'm left with -z equals -6, which gives me z equals 6. Now, because you have z, you can plug z in here for one of the systems, and you can find x. So that's exactly what I did. I plugged in the formula -2x plus 3z equals -8. I plugged the 6 in there, so it was -2x plus 3 times 6 in parentheses equals -8. That gave me -2x plus 18 equals -8. Then that gave me -2x equals -8 plus 78. I'm sorry, I'm having trouble reading my handwriting. And then, sorry, I'm having trouble reading this, but then it gives me -2x equals -26, and x equals 13, because these are both negative, so, and if you divide -26 by -2, it gives you +13. Now, you have what x equals, and you have what z equals. Now, to finish this out, you have to find the amount of triangles, which is 13. From up here, you have 13 right here, and you have the amount of pentagons, 6 right here. And now you have to find the amount of rectangles. So to do that, you would plug in x, you would plug in all the variables you have right now. So I can plug it into the easiest formula, x plus y plus z equals 40. And the easiest formula, because you can just put 13, and you have z, so plus y plus 6 equals 40. Then you got 19 plus y equals 40, and you got y equals 21. So now you conclude that there's 13 triangles, 21 rectangles, and 6 pentagons. That is my math project for chapter 6 and chapter 7. Thank you very much. I appreciate it. I have 30 seconds left over, so you said we could talk about our spring break if we needed to fill in some of the time. So I went to Cabo over spring break with my older brother, who goes to University of Michigan. He's studying business there. And we went with his girlfriend's family, and we spent about 5 days there. It was really fun. It was nice to see him. I haven't seen him for about 5 months, and yeah, it was just some good family time. Hope you had a good spring break as well. Thank you.